Hi, and welcome back to the final section, part of section 6.4. In this last section, we're talking about this idea of the fundamental theorem of algebra. This is really cool because this says that given any polynomial function of degree where n is greater than or equal to 1, so starting with a linear polynomial function and going higher, then n has at least one complex zero. What does that mean? Complex zero means that there will be exactly n complex zeros. So if it is a first degree function, there will be one complex zero. If it's a second degree function, there will be two complex zeros. The idea, though, is what is a complex zero? Remember, a complex number is made up of two pieces, an imaginary piece, the I, and the real piece. So a complex number has both real and imaginary. So when we talk about complex zeros, we're used to talking about real zeros, and we find those real zeros on the x-axis. But we could also have imaginary zeros, which we can't see on the x-axis or anywhere else, which means we'd have to find those algebraically. Remember that anytime you're dealing with a imaginary zero, imaginary zeros always follow in pairs. We call those conjugate pairs. A plus bi and a minus bi. What makes them conjugate is the a's are the same and the bi's are the same. What makes them different is one's positive and one's negative. So complex or imaginary zeros always go in pairs. So let's find the complex zeros to this function or this equation, x cubed plus 2x squared minus 3. The first thing I want you to do is convert it to a function, so f of x or y equals, and graph it. And think about the shape of this cubic function. What's the end behavior? It's different because it's cubic. Left end is down and right end is up because of the positive leading coefficient, which tells us by the fundamental theorem of algebra is that there should be exactly three complex zeros. However, some may be real and some may be imaginary. So we're going to convert it and we're going to graph it using this window setting. And you see that, yep, I have one real zero, and I'm looking at the complete graph, and I have one real zero, which means I must have two complex imaginary zeros. There's one real, so again we have two imaginary. Remember, imaginary zeros always go in pairs. So we take the leading coefficients, but remember we have to have every term, x cubed, x squared, x, and then a constant, and I don't have an x, so that's why I have a zero here. And we go through our process of multiplying by what I know to be the zero at x equals 1, making sure I get a 0. And now that these three numbers here on the end tell me those are the coefficients of my quadratic factor, x squared plus 3x plus 3. Now this is where I can't factor this quadratic, so I have to use the quadratic formula. And when we use the quadratic formula and substituting our values in, we end up with our two conjugate pairs here. X equals negative 3 halves plus or minus square root of 3 divided by 2 times I. Those are our complex imaginary zeros that we cannot see on our graph. So let's go back over this whole section. We're talking about dividing polynomials using synthetic division. And we're going to solve these cubic equations using the synthetic division because we have to understand this relationship between factors and zeros. A factor is something that is multiplied together to get a polynomial equation, but a factor is related to the zero using the zero factor theorem. For example, if x plus 2 equals a factor, then the solution x equals a negative 2. Negative 2 would be my solution or my zero or my x-intercept. We use this idea of the fundamental theorem of algebra to let us find all the complex solutions of a polynomial function. The fundamental theorem of algebra says if I have a quartic function, I'm going to have four complex solutions. Some may be real, x-intercepts, and some may be imaginary, which I don't see anywhere. And our job is to use synthetic division to help us find all of these solutions. At this point, we're going to do 6.4 lecture quiz in class together, but the homework for this section won't be due until Monday, October 22nd at midnight. See you in class.